Okay, this lesson's really going to be about lesson 3C and 3D, but there is one idea we're going to touch on from lesson 3A, and that's the idea of qualitative and quantitative information. Qualitative information is descriptive of non-numerical qualities. For example, qualitative descriptions might be things like, if you're talking about a metal, the fact that it's shiny, or what color something is. If you wanted to describe me qualitatively, you might say something like brown hair and blue eyes. You might describe a person as being a hard worker or being lazy. These are qualitative things. Quantitative data means it has numbers. I have brown hair and blue eyes, but I'm also 5 feet 1 inch tall. You might buy 3 pounds of bananas. You may earn $9.50 per hour. All of that information is quantitative. It has a number. So, if it says a local hospital claimed that many of their patients are happy with the services provided by their hospital, that's qualitative. Their patients are happy. That's nice. But if the local hospital claims that 87% of their patients are happy with the services provided by the hospital, that's quantitative. Think about the headline. 12 people every year in the U.S. are killed by bee stings. Assuming there are approximately 313.9 million people in the United States, what other ways could this headline be written? There may be more than one correct answer. Choose the equivalent statements and select all that apply. Okay, let's look at A. 1 in 25 million will die this year in the U.S. by bee sting. Well, we need to think about this. We know that's 12 people. Is that 1 in 25 approximately? Let's see. 314 million divided by 12. There's 12 people. Comes out to be about 26.1. I think that makes this a reasonable claim. 1 out of every 25 million people. It's true this is a little more than 1 out of 25 million people, but that's okay. Bees claim 1 life every month in the United States alone. Well, there's 12 deaths. There's 12 months. So yes, that is about average of 1 per month. That doesn't mean every month has 1, but I think it's reasonable to say something like this. I would want to put something in here on average. I'd want to be careful. Chances of being killed by bees in the U.S. are 3.9%. Do 3.9 people out of 100 people die? I don't think so. That's somebody who wasn't paying attention to the fact that there's 12 people if you did 12 out of 314 or 313.9, that probably is 3.9%. It is, but that's not right because this is 313.9 million. So it's a much, much smaller. This is clearly inappropriate. Someone you know may be stung by a bee. Well, that's true, but that doesn't equate to that headline that 12 people every year in the United States are killed by a bee sting. So both of these are clearly not equivalent. All right, so moving on, we want to look at estimating sales prices. That's a really practical skill. You've been shopping for a new cell phone and you found one on sale. What is your estimate of the sale price? Try to make your estimation calculations mentally. You may write down your work if you need to, but don't use a calculator. Okay, 20, what does it mean if something's 20% off? Well, 20%, I'm not sure how good you are with your fractions and your decimals, but you know that 10% is 1/10. 20% is twice as much. It's 2/10 or 1/5. So it's going to be 1/5 off. Or you will pay 4/5. So another way you can think about it is if something's 20% off, you pay 80%. 80% is 4/5. All right, well, let's see. The price is about $88. So what is 4/5 of $88? That might be hard to do without a calculator. We can do it, but you could make it a little bit easier if you rounded that to 90. 5 will go into 9. It's going to come out to be, I'm getting approximately, let's see, trying to decide the best way to do this. 4 times 90 is 360 divided by 5. So that's going to be about $72. That's not exact, but that's an estimate. They wanted us to try to just see if we could figure it out. I did show some work. Okay, there are different strategies. Like I say, what does it mean if you pay 20% off? You pay 80%. Or you can think of this, 80% is 4/5. Now, another way that you can do problems like this is you can say, look, the phone cost $88. What is 1/10? Let's see. Let's think about this. If you're going to pay, you know that 1/10 of $88 is $8.80. you're going to pay 8 of those. So you could kind of that's approximately $9. You're going to have to pay 8/10. So you need to do that times 8. And again, I get a rough estimate of around $72. All right. We want to understand that there's some standard benchmarks that can be used in estimation. We want to look at different strategies. We want to think about percentages. Some of the standard benchmarks to estimate percentages are things like 1%, 10%, 25%, 33%, 50%, 66, and 75. Those are some of the more common ones you're going to see. Let's just go on and see what we accomplish. Knowing some estimation strategies and percentage benchmarks allows you to make quick calculations when it is inconvenient or unnecessary to calculate exact results. There are many good estimation strategies. It is important that you develop strategies that make sense to you. A strategy is wrong only if it is mathematically incorrect. You can refer to the resource Rounding an Estimation for examples of estimation strategies. Estimations help you make calculations quickly in daily situations. This next problem shows how estimates of percentages can be used to make comparisons among groups of different sizes. A law enforcement officer reviews the following data from 2 precincts. She makes a quick estimate to answer the following questions. If a violent incident occurs, in which precinct is more likely to involve a weapon? Make an estimate to answer this question and document your strategy in their notes. Well, look, for precinct 1, if there are 25 violent incidents, about 5 of them involve a weapon. Well, I know that 5 out of 25 is about 1/5 or 20%. Remember, we said that earlier. 1/5 is 20%. This one's not as obvious. 18 out of 122. I may want to round that and say, that's about 20 out of 120. That's about 1/6. 1/6, and you probably don't need to know this, is about 16%. So it's a little more prevalent. 1/5 is bigger than 1/6. You have a credit card that awards you a cash back bonus, which means that every time you use your credit card to make a purchase, you earn back a percentage of the money you spend. Your card gives you a bonus of 0.5%. Estimate your award on $462 in purchases. Document your strategy in your notes. All right. There are certain percentages that are really easy to calculate, and the ones that are easiest to calculate are 1% and 10%. A lot of times I can figure out other percentages just using that. In this case, 1% of $462 is $4.62. You just divide by 100 to get 1%, okay? Your card gives you 0.5 or half of a percent. Well, half of that would just be $2.31. I didn't even need to estimate because it was really easy to find 1% and then get half of that. Calculating sales prices. Being able to calculate with percentage is also very important. In the last activity, an estimate of the crime data may help the officer decide about staffing. But if she's writing a formal report, she will need exact calculations. When might someone be satisfied with an estimate of the cell phone sale price, and when might an exact calculation be needed? Well, when you're actually purchasing it, you need to know the exact price. If you're only wanting to compare or get a ballpark for your own thought whether you can afford it, then an estimate's probably fine. Earlier, we estimated $72, but that's not the exact figure. So in Part D, we want to understand that both estimation and exact calculations are valuable skills. Sometimes we need to be exact, but oftentimes we can get by with estimating. There are multiple strategies for calculating percentages. You will be able to determine when an estimate or an exact calculation is appropriate, calculate the percent one number is of another, calculate the percent of a number, including situations involving percentages less than 1. Find the exact sale price if the phone is 20% off. Justify your answer. Well, remember, if it's 20% off, that means we are going to pay, this is full price would be 100% minus 20%. We will pay 80%. Okay, how do you calculate 80%? To calculate 80%, you change it to a decimal, and you would do 80% times, 80% means 80 over 100, or 0.80. So this is percent, fraction, decimal. 0.80 times 87.99. Now you need that calculator because we're not estimating. 0.8 times 87.99 comes out to look like this. 70.392. Now, money only goes to the hundreds place. So the actual price would be $70.39. What did we get for our estimate? We were pretty close. Our estimate was $72. The actual price was $70.39. So if we subtract and we get that difference, we were $1.61 off. It's a pretty good estimate. Calculate the exact answers for the situations given. You may use a calculator, or you may use, we want a document, so let's just go there. If something is 25% off, how much do you pay? You pay 75%. So you will pay 0.75. The original price was $87.99. Again, we need our calculator. 0.75 times $87.99. Here's what my calculator gives me. But again, money doesn't go that far. Money stops right here. So we're going to pay $65.99. If it's 35% off, we're going to pay 65%. So 0.65 times $87.99 That comes out to be 57.1935. Again, we stop right here. So the sale price would be $57.19. If it's 70% off, we are only going to pay 30% of the original price. That's $26.397. This time we need to pay attention because we're rounding here. That 7's going to round up. So our price will be $26.40. Refer back to the table of crime reports from the previous activity. For each precinct, what is the exact percentage? Round to the nearest whole percent. So if we're going to do exact percentages, to take a percent, remember our formula is we do part over a whole. That's really the only time percents are appropriate. And we multiply that times 100%. So 5 over 25 times 100. And that comes out to be exactly 20%. If we do 18 over 122, our calculator is going to give us 14.754, but it says to round it to the nearest whole percent. So to the nearest whole percent, that's right here, we look, that's going to round up to 15%. Calculate the exact amount of your cashback bonus if your credit awards was 0.5% and you charge $462. We actually did it exactly before because I thought it was easy to be exact. If you multiply, remember 0.5% means 0.5 over 100, or 0.0005. So we would do 0.005 times 462. And that gives us $2.31. But I really like what I did earlier. 1% means divide by 100. It's 1 over 100. 1/100th of 462 is $4.62. 0.5% is exactly half of 1%. That's an easy number to divide in half, and it was $2.31. A $119.99 phone is on sale for $86. Estimate and then calculate the percentage discount, rounding it to the nearest 1%. Okay, so we want to estimate. So our phone is about $120, and they're going to sell it for $86. We can do that without using a calculator. That's going to save us $34. So 34 out of 120, to me that looks like it's about 30% off. That's my estimate. How did I get that? Well, I know that 30% is 30 over 100. Well, this 34 is a little bigger than 30, and 120 is a little bigger. That was just my guess. If I want to do it exactly, again, remember, anytime we want to be exact, we put a part over a whole. And then if we want it to be a percent, we multiply by 100%. So 34 over 120 times 100% came out to be, whoops, 28.3%. Oh, let's see. Oh, they want us to round it to the nearest percent. So if I round it to a nearest whole percentage, so my 30% estimate was pretty good. Wasn't exact, but it was pretty close. Okay, we'll do more practice with percents on our Tuesday meeting.